A force is described as a rate of change in momentum with time. This is a more complete description of Newton's second law of motion than you may have previously come across. Newton's second law, as the sum of forces on an object being equal to the mass of the object multiplied by its acceleration, is still true. This new definition allows for more detail. Momentum is mass times velocity. Acceleration is velocity divided by time. Therefore, change in momentum divided by time is the same as mass times acceleration. The descriptions of the effects of force are the same. A change in the direction of the force leads to a change in the force. A decrease in the mass leads to a decrease in the force. The only difference here is that we can now use a combination of mass and velocity to describe a situation. If we know the momentum of an object changes, we know there must be a force at work. We can also infer a completely new property of objects subject to forces. This property is called impulse. The impulse acting on a body is the combination of the force on an object and the length of time that force is applied for. Impulse is force times time. If force is change in momentum divided by time, then impulse, being force times time, is also equal to a change in momentum. Impulse gives us an idea of how long we need to apply a force for to get the desired change in momentum. If we apply a force for a longer period of time, then we'll have a larger change in momentum, so that the mass of an object doesn't change. A greater impulse will result in a greater change in velocity. This is essential in the design of many different engineered scenarios. When a rocket lifts off, it needs to achieve a certain velocity before it can escape the pull of the Earth, the escape velocity. Using impulse, we can calculate the force we need to apply and how long this force needs to be applied for in order to achieve this escape velocity. In the design of crumple zones in cars, we can use the concept of impulse to calculate the amount of time we need the zone to crumple for in order to reduce the velocity of the car below a certain threshold. Treating force as a rate of change in momentum with time allows us to investigate and manipulate forces in a new and more useful way. As with all aspects of physics, the concept of force and momentum can be graphed. If we plot a graph of force against time, we can derive values from the gradient of the line and the area under this line. In this instance, we are interested in the area under the line of a force-time graph. This area represents the impulse of the force and is also the change in momentum of the object.